Alright, so we talked about power series, the definition of a power series, how it can be written, and I told you how to tell where it's centered, right? So if we write our power series like this, or like this power series is centered at 0 because we're not subtracting anything here. This power series is centered at C. So whatever number is there, that's and it's minus in the formula. Keep that in mind. So like if this was x minus 2, it would be centered at positive 2. Right. And so if there's a plus in front, it's centered at the negative of whatever number you have there. And then we went over, we were talking about an interval. You know, when we look at these things, wherever they're centered around, that's actually an x value, a number on the x-axis. And I know I put an x here. It's C. It's considered to be C by definition, but C is an x. So either the power series only converges at one point, it converges at every point on the x-axis, or in some cases it's going to converge just in some interval. So it'll have an interval of convergence. And we'll be able to figure out that interval of convergence by figuring out the radius of convergence. And then what the radius is here, it's not the same as the radius of a circle. The radius, if we figure out a radius of convergence, we actually get out a radius of convergence, some number. That's going to be the distance from C, where it's centered, to some other number on the x-axis. You know, this will be some value, some actual number. And then so you'd want to go the other direction as well, that same distance, whatever we get, and that'll be some other number. Okay? Let's just call this like x sub 1 and this x sub 2. These are both x values. So the interval of convergence is going to be from x sub 1 to x sub 2. And we don't know whether to include these endpoints or not. We write parentheses if we don't include them. We write brackets if we do include them. So I mean, there's a lot of ways that this could look. You may have a bracket if you include that. Who knows? You may be able to include the first one but not the second one. Who knows? You may be able to include both of them. So you're wondering, well, how do I know whether to include them? Well, let's not get too far ahead of ourselves. But the way that we'll know whether to include them is when we plug them back into the power series. Does that converge or diverge? Okay? How do I know that? By using those tests we've been going over. You know, the nth term test, the integral test, p-series test, limit comparison test, root test, ratio test. You know, a lot of those can be used once you plug them back in. Okay? But we have to be able to find the radius of convergence. And if you can't find the radius of convergence, like whenever you find the radius of convergence, if you get it equal to 0, that means the radius is 0. That means that there's no wiggle room from that C. No, you can't move any to the right or any to the left. So this value here, this right here, is the only point where it's going to converge. So you won't have an interval of convergence, so you'll just have a point. That's when R equals 0. And I'm going to show you how to find these. I just want to kind of go back over this really quick. Now, if you get R equals infinity, when we solve for the radius of convergence, that means that your radius is infinite to the left and to the right. Alright, and so that means that all values of x will work out. Now, if we get radius of convergence equals some number, I'm going to call that number L, then that's how once we know where the center is, we'll just go to the right of that number and the left of that number, and we'll get our endpoints, and we'll have our interval of convergence. Okay? So let's look at a few examples. So let's find the radius of convergence for summation n equals 0 to infinity of n factorial times x to the n. Alright, now the last thing that I told you the other day, the last class meeting, was that we will use the ratio test to figure out the radius of convergence. So you have to remember what the ratio test says. Your book uses, instead of a sub n and a sub n plus 1, it uses u. So u sub n and u sub n plus 1. Alright, and so this is how they write the definition. It means the same, just changing the variables doesn't do anything. And so we're going to work this out for our power series. And then after we do that, we should get a number. So if we get, what are the rules for the power series again? Let me see. If you don't have a copy of the table and you want to just look in your book, let me tell you what page it's on. 632. Now if you don't have a copy of this table, you probably would want to make a copy of this table because it's a very good table to use. Especially since we've already had a test on this, I'm going to let you use it on the next test. And you can see the ratio test. If it's less than 1, converges. And it is absolute values. Don't get those absolute value bars. If it's greater than 1, it diverges. If it equals 1, inconclusive. So we've got to do something different. Alright. So that's what we're going to do here. Okay. Since I pulled that up, I have to load back to this other section. Give me just 1 second. Alright, I'm here. Okay. So, let's say the limit as n approaches infinity of, now remember what we want in here. We want u, and that's like our a sub n plus 1, so we have to figure that out. A sub n plus 1 divided by a sub n. Okay, so here's our a sub n right here. That's our, or the way your book calls that, u sub n, means the same thing. Then u sub n plus 1, you simply plug in n plus 1 for every n. And right here, make sure you do it in parentheses because it's a factorial. So that's going to be n plus 1 factorial times x to the n plus 1. Alright, so that's what's going to go in your numerator, and then your denominator is going to be n factorial times x to the n. So n plus 1 factorial x to the n plus 1 divided by n factorial times x to the n. Remember, this is the ratio test. Ratio test, ratio test. You have to remember that because something we're going to do in a second is going to depend on how the ratio test works. Okay, so now simplify. Well, how does this simplify? Remember, you can simplify factorial by reducing by 1 and making a product. It's just with your last whatever you have to put the factorial sign behind it. So I can reduce n plus 1 factorial is n plus 1, reduce that by 1, that would be n, and I'm going to stop there. So this that I have written is the same as n plus 1 factorial. I stopped there because in my denominator I have an n factorial. Alright, and so I want those to cancel out. That's why I'm reducing this top here. Now this, what do powers mean? If I'm adding, that means you're multiplying. So you can rewrite that as x to the n times x to the first. Okay, and then that's all over x to the n. So what cancels out? That does and that does. So I do have the, I just dropped my absolute value bars. I mean, technically, what has to be positive is going to be this x value. So anything to do with the x is what has to be positive. This is always going to be positive, so it's not going to matter. Okay, I'm going to rewrite this though with all that stuff canceled out, so I can show you what's next. So we have n plus 1 times x to the first, and I'm going to write it as the absolute value of x. Why absolute value? Because again, this is always going to be positive because we're just plugging in numbers from 0 to infinity. Alright, so that'll always be positive. We don't know about this because we don't know what to plug in for that. Alright, now that I've kind of separated my limit part here and my variable part here, I can write this as the absolute value of x times the limit as n approaches infinity of n plus 1. So I'm just writing my variable part that I have really no control over. No matter what n equals, it's not going to change this right here. Okay? I'm just writing it in front. And I'm keeping it in absolute value bars because it has to be in absolute value bars because that's the way that the ratio test works. Now remind me, what does the ratio test say about convergence? Because that's what we're trying to figure out. We're trying to figure out, you know, when would this thing converge? When the absolute value of x is less than 1. Okay? When the absolute value of this is less than 1, this will converge. However, when I take the limit as n approaches infinity here, what is that going to equal? Now, if this is less than 1, then it's going to converge when this is less than 1. But I still can work this out. What is that? Infinity. Right? That's never going to be less than 1. So the absolute value of x times infinity is just equal to infinity. There's no way that that can be less than 1. Okay? If it's a positive number, because it's absolute value, times infinity, it's not going to be less than 1. So our answer was infinity. Now you may think, so that means that the radius is infinity? No, it's actually, it doesn't mean that the radius is infinity. It means that it's going to diverge for everything other than at the point where we're centered. Okay? So if you get infinity out here, so you work all this out using the ratio test, pay attention, you work all this out using the ratio test, you come down to the end, and then your limit part goes to infinity, that means that you're going to diverge everywhere. So your radius of convergence is going to be equal to 0. And remember what that means. If the radius of convergence is equal to 0, we're looking at this one point. We don't know, we have to figure out where our power series is centered, but it's only going to converge at that one point where we're centered, because the radius of convergence is 0. So there is no interval. It only converges at that one point. Okay? So now the problem did not ask, where does it converge? There is no interval of convergence. There is the radius of convergence we got to be equal to 0. Where is this thing centered? At 0. So only at the point x equals 0 will this thing converge. Right. Which that would always be 0. Multiplying it times whatever's in front. So if any of that confused you, when you work it out, you work out your limit part with your n and you get infinity, your radius equals 0. Okay. Very important to remember that. Infinity here, radius of convergence is 0. So it only converges at the one point. Alright, let's look at this example. So say I had summation n equals 0 to infinity of 3 times x minus 2 to the n power. And I want to find the radius of convergence. Alright, so this is our u sub n, this thing right here. So our u sub n plus 1, plug in an n plus 1 for every n. So it's going to be 3 times x minus 2 to the n plus 1. Alright, let's do the ratio test. The limit as n approaches infinity of the absolute value of u sub n plus 1, so that's 3 times x minus 2 times n plus 1, over 3 over x minus 2 to the n. That's the limit as n approaches infinity. Now we need to rewrite these things into what they actually mean so that you can cancel them out. The 3 over the 3 cancels out, so this x minus 2 to the n plus 1, that's x minus 2 to the n times x minus 2 to the first, over be x minus 2 to the n. So you see these cancel out. Look, I'm not left with any n at all, am I? I'm left with the absolute value of x minus 2 to the first power. Alright, so there's nothing to evaluate in my limit. So this right here just equals the absolute value of x minus 2. Now we want to know the radius of convergence. When does the ratio test converge? Look at your sheet. When it's less than 1. Okay? So when this is less than 1, we have to write, right here, this is where we start our math to figure out the radius of convergence. So we want this thing to be less than 1, because we're trying to figure out convergence. So how do I solve that? Does anybody remember how to solve absolute value equation? You write it down. If you want to, or how did you learn how to do that? Think about it for a second. Yeah, you could do that to get the endpoints, I guess, if you wanted to. if you want to get the endpoints, what would we could do it like this. We could say, okay, x minus 2 equals 1, and then x minus 2 equals what? Negative 1? 2 plus 2. This is giving us endpoints. Now, this isn't giving us a radius of convergence. So, on our interval of convergence, now here on the number line, we're centered somewhere, and then 3 is an end point, and 1 is an end point. Now you could probably figure out just by looking at this where you're centered, but you could also look back here and tell where you're centered. You're centered at positive 2. That's right. So what that means is, what is your radius of convergence? Your radius of convergence is equal to 1. Now, we could figure out, the problem doesn't ask us for the interval of convergence, but we could figure out the interval of convergence by these two answers that we just got. The interval of convergence is going to be from 1 to 3. It's just we'd have to test these endpoints to tell if we include them or we don't include them. That's what we would plug in for the x in the power series and work it out and see. But this problem did not ask me to find the interval of convergence, even though it all works together, and it's all, if you can understand the interval of convergence, then you can most definitely understand the radius of convergence. Okay? So, yeah, that's not too bad. Because if we figure this out using endpoints, we figure out the two endpoints here of our interval of convergence. This whole thing is the interval of convergence. The distance from the center to the endpoint is 1 unit. And this may make a little more sense as we work examples and we get into actually doing the interval of convergence. All right, let's look at one more example. So with the first example, we got out infinity whenever we worked out our limit. And so that made our radius of convergence equal to 0. So it would only converge at that one point. We worked out another problem, and we got some type of absolute value equation we could work out and get our endpoints from. And then from those endpoints, and you know what the center is by looking at the original power series, you could figure out the radius of convergence. You know, in a graphical sense, that's the easiest way to understand it, in my opinion. Of course, my opinion doesn't really matter. But now, let's see, something else is going to happen now on this one. So we got out infinity. That gave us one radius of convergence. We got out a number, or we had a number there, or an equation there at the end that did something. Now, let's see what happens if we have this power series. Let's say we had -1 to the n times x to the 2n plus 1 over 2n plus 1 factorial Alright, so Can you tell where this is centered? Yeah, I mean, your A is just it's going to be all this stuff. So this is still centered at looks like it's centered at 0, I believe. We don't have to know that. So let's find if this is our u sub n or our a sub n. Let's find our u sub n plus 1 because that's the numerator part of our ratio test. So that means plug in an n plus 1 for every n. Now be careful here because if you're not careful when you plug in for this one, you'll forget that you have to say 2 times n plus 1 and then you have plus 1. You gotta be careful on that one, it's kind of tricky. And then same here, 2 times n plus 1 plus 1. Alright, so we have negative 1 to the n plus 1 times x. Let's see, that's going to be 2n plus 2 plus 1. So that's 2n plus 3 over 2n plus 2 plus 1. So again, that's 2n plus 3, but that's factorial. So this is the numerator of our ratio test. Now, if we have to divide by this, isn't that the same as flipping and multiplying? Yeah, so if you have a fraction, you can save a step. You don't have to put divided by all of this by just flipping and multiplying it. Alright, and it's the absolute value of all of that. So the absolute value is going to eliminate those negative 1 to any power. All of those remember, are generators. Positive and negative generators. The absolute value destroys those. Alright, so the absolute value gets rid of those two. We don't have to worry about that. Alright, now we need to rewrite this and rewrite this, rewrite this and rewrite this. We need to rewrite everything so that we can simplify this expression. Okay. Limit as n approaches infinity, absolute value x to the 2n plus, oh no, I need to rewrite it. So that's going to be x to the 2n times x to the third, right? Now, which factorial do I need to rewrite? The top one or the bottom one? The bottom one. Because remember, whenever you rewrite ooh, look what I did. Y'all let me do that. You should have shunned me. You got to put that factorial on the outside, not after the 3. And the reason why you have to simplify the bottom is because you subtract, right? So I'm going to simplify the bottom factorial. That's going to be 2n plus 3 times 2n plus 2. I'm not quite there yet. So times 2n plus 1. I stop there. It's really neat how, in my opinion, how this and this actually give you the same answer. But anyway, so I stop there because that's what your top factorial is written as. Alright, and then don't forget this bottom term right here. Rewrite it. That's x to the 2n times x to the first. Alright, so there, cancels out. There, cancels out. This x to the first will cancel out one of these x's and make that to the second. So I have the limit as n approaches infinity of x squared over 2n plus 3 times 2n plus 2. Why was I able just to drop those absolute value bars? X squared is always going to be positive. That's right. So the absolute value bars, while you could write them there, they're not necessary. All right, it's just kind of like overdoing it a little bit. And remember, the absolute value bars only go with the variable part of x, not with the n, really, because n we know is going to be positive. All right, so here's what we have. We have x squared times the limit as n approaches infinity of 1 over 2n plus 3 times 2n plus 2. So what is this term going to equal? X squared, when you let that be infinity and that be infinity, it's 1 divided by infinity. So that's going to be 0. Now, you're going to get out a 0 right here, but that's not the radius of convergence, because the actual radius of convergence is the x values, not those n's. We're looking at x values. We want to know, where does this thing converge? So you can plug in any number for x, and you're going to get the same answer out. You're going to get 0 every time. So it doesn't matter what x is. X can be any number. So that means that the radius of convergence is going to be infinity. It's weird how whenever you get out infinity when working out one of these problems, the actual radius of convergence is 0. But then whenever you get out 0, that actually means the radius of convergence is infinity. So it's going to converge for every point on the x-axis, every number of x. So you have to remember that. You have to remember it's kind of like the opposite of what you would expect because of the way that it interacts with the x values, whatever you get here. Okay. Your book says for any fixed value of x, this limit equals 0. So by the ratio test, the series converges for all x. Which is true. It converges for every x. Because it doesn't matter what x is, you'd still get out, times 0. So the radius of convergence is infinity. All right. Now that one problem, that one where we actually had an equation to work with, where we found endpoints. That's the only one really that we had an interval of convergence. And we didn't know whether the endpoints would converge or not. So we really didn't know what to do. I like this little illustration that your book has, so I'm going to copy it over and let you look at it. I know I told you whenever I think about these power series or different series, I like to think about them on a number line. And it makes the most sense with these power series because on that number, that x-axis, all those numbers are the numbers that we want to know. Would we be able to use them in the power series to get something that's convergent? And here's just a little illustration of what we just did. The first problem we worked out, we got our radius of convergence was 0. So it's only going to converge at that one point, wherever your power series is centered. Then if you get out infinity when you work the limit, the ratio test for these, then, if you get 0 out, that means the radius is infinity. So for every number on the x-axis. You could plug anything into that power series for x, and it's going to converge. Now, these are the ones where we're kind of putting a restriction on things. You know, only from this number to this number. And this is how the radius of convergence works. From the center to the end point, you know, is one distance. From the center to the end point in the other direction is that same distance. And so either we could have it parentheses, both parentheses, you know, we have all these different options. We have to figure out, though, does it converge at the end point or does it diverge at the end point? And we'll do that by plugging the number in and actually doing a different test to see. All right, so let's say that we wanted to find the interval of convergence. So let's say I had this series. N equals 1 to infinity, x to the n over n. Okay? So, where is that centered at? 0. For all this to make sense, in my opinion, like your book will go through and it may say it somewhere in the problem, but I like to figure that out first in case I need it in my problem somewhere. So we know this thing is centered at 0. And what 0 am I talking about? I'm talking about at x equals 0. This is centered on the x, if you think about a number line. All right. So this is our a sub n, or our u sub n, like your book calls it. So find your u sub n plus 1. You plug in a n plus 1 for every n. That's the next thing I would do. So this is going to be x to the n plus 1 over n plus 1. The ratio test is the limit as n approaches infinity of u sub n plus 1. So this thing, this absolute value, this thing, divided by this thing, divided by your a sub n. And if you're going to divide by a fraction, you might as well save yourself that step and flip and multiply. Now, rewrite what you can. There's only one thing we can rewrite here, and that's that thing right there. Those cancel out. Now the absolute value bars are only going to affect this x, and since it's a product, I can rearrange this and say the absolute value of x times the limit as n approaches infinity of n over n plus 1. Alright, so what is that limit equal to? That limit is equal to, so that's equal to the absolute value of x times 1. So, for the ratio test to converge, the absolute value of x has to be less than 1. I like to do it like this. The book is not going to explain it exactly like this. This makes the most sense to me to write down that. And then I get my two endpoints. I can get my endpoints right now. As long as I have the absolute value of x or absolute value of something, I can figure out the endpoints of my interval of convergence. So it's x equals 1 and x equals what? Negative 1. That's the way absolute value works. If you have an absolute value equation, you say what's inside the absolute value equals the right side, and then what's inside the absolute value equals the right side, the opposite of the right side. Okay. And so those are actually my endpoints on my interval of convergence. So if I had a number line, these are all my possible values for x. If I have negative 1 here, and I have 1 here, that's my interval of convergence. I just don't know whether I can put parentheses or brackets with those. Now your radius of convergence was also 1. Okay? You can see because the distance between the center and the endpoint was 1. Now the problem didn't ask for the radius of convergence, but that's what it was. Okay. So now, to figure out if our series converges or diverges, we have to go back and look at our power series here. And we plug in a -1 for x in parentheses because it has a power. And then we'll figure out if that converges or diverges. Then we'll plug in a 1 for x. And we'll figure out if it converges or diverges. Okay, so let's plug in the -1 first. So I have summation n equals 1 to infinity of -1 to the n, right, if I plug that in for x, over n. Alright, so this is where our skills that we learned in the first 6 sections have to kick in. And you can use your reference sheet. So what you do kind of need to recognize what type of series this is. Now the -1 to the n in the numerator kind of tips us off as to what type of series this is and what type of test we should use. That should lead you towards using the alternating series test, more than likely. Okay? I mean, this is 1 over n is called the harmonic series, and this is an alternating harmonic series which always converges, but what I would do is I would use the alternating series test. So what are the 2 conditions this will need to meet in order for it to converge? The limit as n approaches what? Infinity. Everybody should probably be looking at their sheet right now, unless you have all this stuff memorized or learnt. Is that a word? Probably not. Learned. And it's the limit as n approaches infinity of a sub n. What is a sub n? It's not this thing right here, not the generator. It's just 1 over n, right? So what is that? Equal to 0. Guess what? We passed the first condition, or maybe that's the second condition. It doesn't matter as long as you do both. All right, what's the other condition? Okay, a to the n plus 1 is less than or equal to a sub n. So this means that the next term is always smaller or equal to, because a sub n plus 1 means next term. So like if I let n, and there, you know, I'm sure you could go through and prove this after you take a class on how to prove things, but we can do this by exhaustion. If my a, you know, if that's a to a sub n, and that's a sub n plus 1. Again, there's a way to prove that mathematically, but I'm not really worried about that here. As long as you understand that, okay, as I plug in numbers for n, like for 1 that would be 1 over 1, for 1 that would be 1 over 2. Yes, that's definitely less than. For 2 that would be 1 over 2. For 2 that would be 1 over 3. Yes, that's less than. So as long as you see that, I don't mind you just kind of writing out a couple, and that's called proving by exhaustion, which technically if a real mathematician like saw me teaching it like that, he might be mad at me because I didn't go through, and you can work that out and figure it out though easily. Anyway, so that's true. It is always non-increasing. Remember, that's what that's called. If it's less than or equal to, it's non-increasing. So step 2 checked out. So they both checked out. So that means that when x equals -1, the series converges because both of those were met. So that means when I write this interval of convergence, I'm going to put a bracket with my -1. Alright, so that was, I probably need to write this to the side. That was for x equals -1. Alright, so for x equals 1, this would be summation n equals 1 to infinity of 1 to the n over n. 1 to the n is not going to do anything, right? So you could just write that as just 1 to the n. Now the 1 to the n doesn't do anything, so you can write it as 1 over n. Sorry, I think I said that wrong. Now there's two ways that you could tell me about what that series is going to do. One is you could probably use the P-series test. The other is you could say, hey, that is a harmonic series, 1 plus 1/2 plus 1/3. That is the harmonic series, the main one, and it always diverges. Or you could use the P-series test and say, well, P equals 1. So it's divergent because P needs to be greater than 1 for that to converge. Less than or equal to 1, it diverges. Or did I say that backwards? Look at your sheet. You need to refresh yourself on all these tests. Just because we've already had an exam on it doesn't mean you don't know how to do it. So what does the P-series test say? If okay, less than or equal to 1, diverges, greater than 1, converges. So you could say that this is a divergent harmonic series or a divergent P-series. Either one is correct. So that means that you put a parentheses with +1. So here is your answer. This is the interval of convergence. What does that actually mean, though? That means that for this power series, right here, including -1, every x value between -1 including -1 to +1 not including, this will be convergent. It's very easy to go through and work these problems and not actually understand what's going on. But it makes more sense if you understand what's going on. It's very hard to break down an abstract concept like this and make it make sense. So I do struggle with that. So if you have any questions, let me know. When x equals, yeah, so like 0.9, 0.99, 0.9999999, it will converge all the way until you get to 1. Alright, here's another example. After this example, I'm going to get you to try one. So, try to make sure I have enough time for that. So I have x plus 1 to the n, -1 to the n times x plus 1 to the n over 2 to the n. So that's my u sub n or my a sub n. So I need to figure out what my u sub n plus 1 would be. So that's -1 to the n plus 1, x plus 1 to the n plus 1 over 2 to the n plus 1. Alright, so I'm going to take the limit as n approaches infinity of the absolute value of u sub n plus 1 over u sub n. So I'm writing down my u sub n plus 1 again. And instead of writing this u sub n in the denominator, I'm going to go ahead and flip it and multiply. I better give myself a little space there. So if I flip it, my 2 to the n is up here. negative 1 to the n, x plus 1 to the n. Alright, so you might want to rewrite some of that stuff from your terms so that you can cancel stuff out. Also, those go away because of the absolute value bars. So it's x plus 1 to the n times x plus 1 to the first times 2 to the n over 2 to the n times 2 times x plus 1 to the n. Now what cancels out? 2 to the n and 2 to the n cancel out. X plus 1 to the n and x plus 1 to the n cancel out. Look, it looks like all my n's canceled out. That's good because that means this will have an interval of convergence I'll be able to calculate. Now, I have x plus 1 in parentheses. That's what my absolute value bars are going to go with. And there's a 2 in the denominator, so let's see what that'll look like. So the limit n approaches infinity of the absolute value of x plus 1 over 2. Now, there is no n value in here. So this is just going to equal the absolute value of x plus 1 over 2. Now, for this to converge, according to the ratio test, this is going to converge when it's less than 1. Okay? So what you can do, this 2 is a constant. So if you multiply both sides by 2, you have the absolute value of x plus 1 is less than 2. So you can figure out the endpoints. X plus 1 equals 2. X plus 1 equals negative 2. Well, that doesn't cancel out. I erased everything except what I wanted to. Alright. So that's going to be... Wait, what am I doing? I got a little happy there, sorry. Minus 1, minus 1. Alright. X equals 1, minus 1, minus 1. X equals negative 3. So, again, think about this on the number line. Who knows what these values are? Maybe they're voltages. They're the minimum and maximum voltages that my circuit's going to be able to handle. I just made all that up. But things like this they do happen in the real world, and they don't always come out to be pretty things like this. But you have to understand how to do it ugly to do it pretty, right? Alright, so there's my two values. Now you can look back at your power series, and you can actually get from this power series if you're on the right track, or did I really mess up? You can tell where this thing is centered, right? So this is kind of like a little self-check. Am I doing this right? This thing is centered where? Negative 1. X equals negative 1. So when I come down here, if the center is not at negative 1, then something's wrong. Well, let's see. Is the center at negative 1? So we'll know if we're right or not. What's the distance from negative 1 to 1? 2 units. What's the distance from negative 1 to negative 3? 2 units. So the radius of convergence is 2 here. We didn't even find that out, but that's what it was. Now we want to know, do we include or not include the endpoints? So let me go through this really quick. So 4x equals negative 3. Let's do that one first. So go back to your power series and plug in a negative 3. So we'll have summation n equals 0 to infinity of negative 1 to the n times, what happens when you plug in a negative 3? What's that going to be? Negative 2 to the n. Where did that come from? Those people who are not keeping up right now. If I plug in a -3, that becomes a -2. -2 to the n. Okay. Over 2 to the n. This is an alternating series. However, if you use the rewriting skills that we went over a few weeks ago, you can rewrite this term right here. What is this the same as? This is equal to, is it -1 to the n times 2 to the n? Just check and see. Alright, so like, if n equals 1, that's -2. n equals 2, that's 4. n equals 3, that's -8. Alright, so n equals 1, that's -2. n equals 2, that's 4. n equals 3, that's -8. So yes, this is how you rewrite this. You say, why would I want to rewrite? Why don't I just go through all that alternating series stuff? That takes a little while. So I can take a little shortcut here, rewrite this, and by rewriting it, you see what happens. Those cancel out. Now I just have this. What does wait, why did I say 2n? -1 to the n times -1 to the n, add the powers, 2n. Okay? What does this do? If n equals 0, that equals 1. If n equals 1, what does this equal? If n equals 2, what does this equal? If n equals 3, what does this equal? It does nothing. Like a bad student. Does absolutely nothing. But unlike all of you who do something. Alright. So this right here is 1. So, what does that mean? What would this series be? It would be 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. On and on forever. Is that going to converge? No, that's going to go to infinity. So that diverges. Okay, so now for x equals 1. Well, that one hopefully will be a little easier. Let's see. I'll plug in a 1. Yeah. It's going to be summation n equals 0 to infinity of -1 to the n. Plug in a 1. You get 2 to the n. Okay, so those cancel out, and they leave you with this. That's going to equal 1 minus 1 plus 1 minus 1 plus 1 minus 1. And since that never ends, that keeps going on and on like that forever, that also diverges. You may say, no, that equals 0. No, that's going to diverge. It just keeps going on and on forever, alternating. Okay. So what is the interval of convergence? Parentheses, -3, comma, 1, parentheses. That is the interval of convergence. So that is all of the x values that you could plug in to that power series and it would converge or go to some number. We don't know what number, maybe. Maybe we're able to figure it out, maybe we're not. But that is where it would converge. So here, you try this one. Summation n equals 1 to infinity x to the n over n squared. Find the interval of convergence. So I'm going to start working this out. We get that's equal to 1, right? So absolute value of x less than 1. So x equals 1, x equals negative 1. Now we plug those in up here. Let's say for x equals negative 1, be negative 1 to the n over n squared. You can use the alternating series test for that, and you'll find out that it converges. It's going to meet both criteria. So that means that that's convergent, so we'll put a bracket with that. And then for x equals 1, 1 to the n over, or actually 1 to the n, right, over n squared. The 1 to the n does nothing. So that is this series. And that's a convergent what? P series. Where, because, and this is P equals 2, and as long as it's greater than 1, it converges. So that means we put a bracket with that. So the interval of convergence is bracket negative 1, 1 bracket. And you can check the center of that at the very beginning. The center was equal to 0, so that does work out like it should.